Hello class. So this is the next video on section 5.1. In the previous video, we saw how to do left Riemann sums, right Riemann sums, and midpoint Riemann sums. Right? Remember, those just mean that you look at the left endpoint of each subinterval, the right endpoint of each subinterval, or the midpoint of each subinterval as the input for your function, right? In each respective. So here we have another example. Find the midpoint Riemann sum of f equals square root of x on the interval 1 through 3 with n equals 4 subintervals. Now, for sake of time, I'm not going to do the whole thing, but I'm going to get you started. So remember, the first thing to do is always find the change in x. Right? That's the length of each subinterval. This is always 3 minus 1, so subtract the endpoints, divide by the number of subintervals. That's 2/4, which is 1/2. Okay. So now I'm going to draw the number line. You don't have to do it, but it always helps me. So we start at 1. We need to end at 3. So how do I know what the next endpoint is? Well, you just add change in x to your left endpoint. So 1 plus 1/2 is 3/2. 3/2 plus 1/2 is 4/2. 4/2 plus 1/2 is 5/2. 5/2 plus 1/2 is 6/2, which is 3. So that's how you can always find the endpoints of the subintervals, right? Just start with the left endpoint, add change in x until you get to the end. Now, we want to do a midpoint approximation. What does that mean? Well, we need to find what this value is. By using the formula from the last section, how do you find, from the last video, sorry, how do you find the midpoint of an interval? Well, add the endpoints and divide by 2. So we're going to do 1 plus 3/2 divided by 2. That's 5/2 divided by 2, which is 5/4. Let me make sure that I did that right. 5/2, yep, 5/4. So this here is 5/4. And remember, all you need to do is find the midpoint of the first subinterval. In order to find the other ones, just add your change in x to the first midpoint. Right, so this one is going to be 5/4 plus change in x, which is 1/2, etc. Add 1/2 again, add 1/2 again. Okay. And now that's basically all you need. Now you can go ahead and calculate the area. So a sub m, again for midpoint approximation. Right. So the length is always the same. So it's going to be change in x. Length of the rectangle is change in x, which is 1/2, times the function evaluated at the midpoint. So f of 5/4. So it's the first subinterval. I need 4, right? Because I need 4 terms in my sum because I have 4 subintervals. So I find the next one. I do 1/2 times f. Just add the change in x to 5/4. So 5/4 plus 1/2. Now remember, 1/2 is the same as 2/4. Right? So we get the same denominator. So 5/4 plus 2/4 is 7/4. Plus, so this is 7/4. How do I get the next subinterval, the next midpoint? Well, again, just add change in x. So 7/4 plus 2/4 is 9/4. So this is 9/4. Finally, I need 4 terms, so I need one more. How do I get the last one? Again, just add the change in x. So 9/4 plus change in x is 9/4 plus 2/4, which is 11/4. And I'm not going to go ahead. You can go ahead and plug in the values into f, which is square root of x, and actually find what you get. I won't do it because that part is the easy part. That's just evaluating a function. Right? The hard part, in a sense, or the harder part is finding what this is. But again, the midpoint or the left endpoint or the right endpoint doesn't matter. Just find the first one in the first subinterval, and then just keep adding change in x to get the other ones.